Great.
Okay, sweet. Okay, so we're back in business. Okay, so you were asking about the relationship of types to APIs, and as forever and a day from the old Corbett days to WSDL to whatever, APIs and types have been identified. Right? So this is pretty much an industry thing, right? You know, the API is a type. Um, uh, and here all I'm doing is setting up the notation that we might think about when we're talking about contracts and types, right? And so the standard notation for writing down a type judgment looks like what I've just written up here. So you've got some Ethereum contract C, and it's going to support some variety of APIs. So when we say that C supports the type or the API T, we write it like that. If it supports this other API U, we write it like that. And in general, part of the reason why you want to relate this to logic is to do exactly what you just said. So for example, suppose that logically you know that you've changed the API a little bit, but you know, or you've changed the contract a little bit, and you want to prove that things are still hunky-dory. Well, suppose that you know that U implies T logically, okay? And if you change C so that C now types as U, right? Then you'll be able to conclude, because U implies T, that C types as T, right? So if all the clients were depending upon T, and you change the contract so that it now does U, then they're undisturbed, because if you can establish that U implies T.
Yeah, I mean that would be great. I'm wondering about the line between, what you can prove from the type and what the client expects from the interface. So like there might be something that verifying the type would mean running the computation that the program ran, right?
Well, in general, you want type checking to not be equivalent to running the computation.
No, but it seems like that would be like the degenerate case. Like
that's the kind of there are certain type theories where that's going to be what happens, but you don't want to do that too often.
I just want to prove myself that doesn't happen because of because like the type system has enough coverage.
Yeah. Well, that's always a balancing act, right? I mean, so for example, the first thing you want to do is to show that type checking is decidable, right? There are going to be lots of type systems. There are variants of Martin-Lerf type theory, for example, where type checking is not decidable. In fact, the Haskell type system is Turing complete. So there are going to be some times when you ask Haskell to type a program, and it's going to say, well, give me a second, and a few million years later it's going to keep saying, well, give me another second, so it won't come back, and those are kind of worst case scenarios. So you absolutely do not want, as best as you can, to have undecidable type checking. That's a bad idea.
Right, but depending on what the contract language is, we may or may not be able to have types that are both decidable and have a sufficient coverage.
There are definitely going to be places where there are things you might want to say with contracts that if you try to say them, then you can't you can't decide whether or not a program is well typed.
Unless you run it, or in general?
In general, right? There are certain cases where type checking is not decidable, and these are well known. So I'll give you an example, right? Even in here, let me grab it. Spatial. Okay, so it's Luis Caires, behavioral and spatial observations in a logic for the pi calculus. There we go. What? Let's try that again. Okay. Let's try this one. Whoa, is Sightseer down? Looks like Sightseer is down. Let me try this in a different browser. That's weird. Seriously. Wow. Looks like Sightseer is down. Holy cow. Okay, well, fortunately, I have a copy of the paper. Let's see. How about I do it this way? All right. Well, I'll have to send you a link. But what that paper is a really good one because he not only gives a logic, but he identifies a very interesting class of programs for which type checking is decidable. So I mean, here's the paper, right? Here it's a Springer, and I'm not sure whether or not it'll let me. Come on. Oh, there we go. It might actually do that. Wow, this is really slow. I'm not sure what's going on here. Okay, so if you look at expressiveness, he talks about this quite bluntly. Okay, so for example, you can build formulae called which are the adjoint to the parallel type, and you can prove that that's not decidable. So you don't want to allow people to utilize those kinds of types if you want the type checking to terminate. You guys still there?
Yeah.
Okay. Okay. Cool. So this is a great paper for seeing some of those kinds of phenomena. So the adjoint to the parallel composition operator at the type level is not decidable, and that's easily proved. Well, relatively easily proved. And then he identifies a class of processes which have recursive definitions and just a bunch of really useful and interesting properties where you can define useful and very expressive yeah, there you go, exactly, thanks Aaron. Useful and very expressive contracts. And so if you identify contracts as processes, which is what I'm trying to do with the contracts for scaling paper, then you see that this is a really nice class of contracts. You can't do anything and everything, but at least they're typable, right? So you basically have two choices, or you have a spectrum with choices at either end. So in the case of like the Hindley-Milner kind of type system, you can get checkability, and the programs are Turing complete, but the types are so weak that you can basically type check any program, right? But the information that the types provide you is less informative than the kinds of things that you're asking for now. So there, what you've done is you've dialed up the expressiveness of programs and dialed down the expressiveness of types. On the other side, you have the system like what Kairos is doing. And I'm sorry, it's taking forever to scroll through this paper. I can show you. He has a nice little theorem. It's pretty close to this page. Darn it. There's a nice theorem in which he identifies exactly the set of processes for which type checking is decidable. I was just looking for the statement of the theorem. But anyway, so what he does is, instead of he kind of dials way up the expressiveness of the types and dials down the expressiveness of the programs. And what that does is that that also guarantees decidability of the type system at the expense of some things you might want to do with contracts. And so this is why I'm saying it's always a balancing act, right? And it doesn't have to be fixed. So this is why I've spent so much time since 2007, once I realized that it could be done, constructing a method whereby, essentially, if you have the specification of the contracting language, and you have as input also the way of collecting contracts, so set, list, bag, whatever. So you have a way of collecting the contracts. Then I can generate for you a type system, and not just a type system, but the type checker. And this type checker then becomes a kind of search engine, which feeds into your service discovery mechanism.
Greg, can you give an example of what you have to give up for stronger, or the kinds of things you have to give up for stronger type checking?
Yeah, that's why I was trying to pull this paper up. This is like one of the best examples I've ever seen of the kind of trade-off. Okay. Another example of the trade-off is in this paper, right? So with this programming language, I mean, the programming language itself is Turing complete, as long as you don't type the programs. But all well-typed programs terminate. Right. Right. So there's an example. You're absolutely giving up Turing complete, but when you type them using this system. So that's why I use this system as a kind of toy, but it's actually a kind of useful toy. It's probably, my guess, if I had to, if someone put a gun to my head and said, what's your best guess on the expressive power of the well-typed programs? It's probably context-free languages, which is not Turing complete, but it's a lot of stuff, right? you can do a lot of cool stuff with context-free languages. And if you think about it, right, what kinds of contracts are people actually writing with Ethereum today? I bet almost all of them will sit easily inside context-free. Right? I mean, most people are writing really simple things like alarm clocks and.
Does the context-free thing relate to the ability to compose the types?
Compose the types.
Yeah, if you're running things like programs concurrently.
No. It's the fact that it the expressive power that this selects out has to do with resource balancing. So with the linear types, the linear types assure that you've never got some dangling resource. You know, every resource is basically anti-double spin. The linear types say that insist that every give is matched with a take. Every buy is matched with a sell.
Well, isn't the idea that it just forces it to terminate? The idea is?
Um, the fact that the linear types make sure that all the resources are accounted for, that's what forces the thing to terminate.
But so, but the reason that I mean is like that the main reason that it makes it easier to type check.
The decidability of the type checking is going to be related to this constraint on, you know, the programs that do type check. Yes, but it's again, the point is you have a lot of freedom, right? You can dial down the expressiveness of the programs and up the expressiveness of the types, or you can dial down the expressiveness of the types and up the expressiveness of the programs, right? It's a balancing act.
So do we go 50-50?
Right. Well, that's why I was trying to show you the chi-race paper, because it does exactly that kind of 50-50 thing. Right? And you have to constantly get a feel for what's going on. And that's why you want this kind of ability to dynamically generate type systems.
Right. So what you want is basically like you program at whatever level of expressiveness you need, and then you generate whatever types you can.
That's exactly. Now, the important thing though is to remember that, you know, you're now talking about utilizing types potentially to do service discovery. So you can't be too fluid in your types, you know, if you're doing it for service discovery, right? Because then, you know, it's like, you know, I'm trying to find a taxi, but I only speak English, and everybody here speaks French.
Yeah. So we looked at this a bit, and the main issue that we found was that if you can, there's kind of like this. So if you want the calls to be atomic and happen, you know, exactly once, but you're matching to a type that might be for different contracts that exist on different shards, you might end up hitting more than one of them.
Right.
So we're trying to figure out how, other than unique identifiers, to prevent this. I guess the thing to do is to like look at the graph of calls after it happens and revert one of them.
Well, I mean, the other possibility is that like if you really want any resource that you need to be conserved, you can again apply consensus to, right? So, you know, if you need like a singleton service, then that's a conserved resource, just like a Bitcoin is a conserved resource. So you can now keep a ledger of singleton resources, whatever they are.
Yeah, but you know, you don't want to force things to be singleton. You want them, you know, you want to also have the ability to have reach it at any different location, right?
Yeah, no, I'm not saying no. Location versus conservation are separate, right? And like, it's not a requirement. How do I say this? Just because a particular computational resource is conserved, right? Which means there's, you know, only one person has a handle on, or one agent has a handle on it at a time, does not locate it, right? It could be, you know, evaporated, you know, sort of frozen, taken off a particular shard and reconstituted on another shard.
Yeah, but it needs to like synchronize with everything before or after in order to make sure that not two of those events occurred.
Correct. Right, but that's essentially where the consensus is coming into play, right?
Right.
Consensus comes into play to assure that everyone agrees, all the transactions up to the freezing event, and where it went.
So I instinctively prefer to execute and undo than to wait for synchronization before executing. So do the calls, synchronize, revert one of them, as opposed to synchronize, do the call.
Oh, wow. Okay. I mean, that's kind of.
Isn't that the same as an optimistic update?
I think that might be right, Casey.
Yeah, but I guess. Yeah, I think there's probably some kind of space-time trade-off there, right? So yeah, it's exactly a space-time trade-off thing, right? So if you can afford the time for reversion, then that maybe is a good idea. Alternatively, if you can afford the storage of having the blocked computation, then maybe that's a good idea.
Yeah, but there's also the latency. So the main thing I was worried about is latency. So synchronization might take a significant amount of time.
Okay. Well, I'm pretty sure we can make an argument, just information theoretically, that the time ought to be the same. And in fact, the thing I'm more concerned about is chasing down all the reversions, because you're going to have this giant graph of dependencies, right?
Yeah,
and
exactly.
tracking down all the reversions may be much, much harder in a distributed setting than just having one localized entity blocked waiting for input.
Right, but so.
And the thing that's worse. Now I remember the problem, because I looked at exactly this in BizTalk, right? So I offered compensating transactions as a kind of semantics, right? So in fact, I have patents on this. I've totally forgotten about all this. So imagine that you do exactly what you're saying. So you opportunistically go ahead because you feel like you have a high degree of confidence that you're going to get the input that you expect or that you need, and you expect it to be of a certain shape, right? So that's equivalent to the poison pill scenario, where you fire, you let the thing go, and then you realize, oh, subsequently I have to kill it with a poison pill, right? So those are exactly isomorphic problems. But if you want to wrap transactional semantics around that, what can happen is the reversions are chasing are chasing the knock-on effects, but the knock-on effects, for whatever reason, are being distributed to resources that are faster than the reversions. So the reversions, they keep fanning out, spreading through the graph, but the knock-on effects are moving at a much greater rate. And this is just by accident, right? Just by who accidentally gets which resources. And so the reversions are falling farther and farther behind, because there's this exponential growth of the graph in the knock-on effects of the dependency that you were trying to revert. And so you can never catch up, right? It's basically Zeno's paradox.
So how we have these like global synchronization things. Let's just say, then with every global synchronization, you can make sure that people aren't like running off like that.
Right. No, that's exactly it. So now you reintroduce a synchronization, right? And now the synchronization is at a much bigger scale, right? Which is worse to me than having the synchronization localized to the input guard. So by going down this path, right? So you've decided that reversion is cheaper than being blocked on some input, right? But reversion leads to this race condition, and then in order to defeat the race condition, you introduce a new synchronization point, right? But that synchronization point is now at a much bigger scale than just a local guy that needed the input. So that seems to me a suboptimal solution.
I mean, we're going to need global synchronization for reverting transactions anyways because of invalid blocks, right?
Right, but you don't need it for this. So why introduce it?
But I mean, it will basically give clients faster calls, right?
No, I don't. We had this conversation a couple weeks ago. I'm not sure. I'm not sure I buy that.
Well, I mean, so for example, do you agree that like you know, if I make certain types of transactions, the kind of non-finalized transaction receipt in like just vanilla Casper would give you might be valuable to you.
Wait, can you say that again? I didn't quite.
Do you think the non-finalized transaction receipts are valuable?
Non-finalized transaction receipts. I don't know.
Good answer. Basically, though, like people will end up like trying it, and they'll figure out on average how bad it is to use the non-finalized transaction receipt for their particular application. And so it could really dramatically reduce the latency. Really, that's the main thing that I'm like thinking about here.
Okay, I actually think that you run the risk of increasing latency by introducing.
So here's the example that I have in mind right now. I'm gonna do a DNS lookup in this scalable sharded blockchain. I'm gonna hit maybe 4 or 5 inter-shard calls before I get to my entry. So I'm gonna have to wait for 4 or 5 synchronizations, which I assume that you, I guess, want finalized global ones before I get my DNS read. Whereas if everything is done optimistically, basically they could all do it very quickly with unfinalized receipts and things, so I could get my read right away, even though in the following however many seconds.
I'm just going to interrupt because I think that's sort of a bad example.
Why?
Because that's not how you would set up a DNS read.
What do you mean? Why wouldn't you have to have multiple layers after a while?
I mean, you'd have a local DNS on your server, and that would synchronize with its parent shard's DNS contract.
So you don't have a server; you're like a client, right? I mean, I'm not assuming that the clients have any piece of the DNS tables.
Right. No, I'm saying the shard would have each shard would probably end up having its own DNS
of course, but how do you
contract.
How do you pick the right one? I mean, this is a service discovery thing, and that's kind of what's going on.
You would always hit the DNS contract that was in your shard.
And then it would tell you which shard to go to for the shard of the DNS table that you need.
What are you looking up in the DNS table? A service, correct?
Yeah, actually, the DNS table is 50 times bigger than the capacity of a shard.
I don't see how that would be possible.
What do you mean? It's a big. You just have a big table, and you have different pieces of the table across shards.
Well, just looking from an internet topology, like my local IPS runs a DNS server, and I always hit my local DNS server. I don't have to hit a global DNS server every time I visit a website.
But
my local DNS server is stored, not far from here. And so yeah, that's just.
Yeah, but if we want it to be on people's laptops in a peer-to-peer decentralized network, we can't really expect them all to necessarily hold the whole thing, right? I mean, I basically would love to.
No, but a single shard I would expect to hold a whole DNS.
I would definitely not. No, I would want to be able to hold tables that are much bigger than that. I mean, I don't know how big DNS is. I just assumed it was big.
Yeah, no, but the important thing there is that the DNS, like in a world where mobile computation elements are coming on and going offline, like I buy a new phone and it gets activated, right? So suddenly I've got a new computational device. So there will be lag in DNS-like information, and it can't. It's like there can't be. The local shards table will always be a little bit out of sync with some other shards table.
Yeah, that's for sure. And then, but the other thing is that, like, it's just to illustrate what I want to say is that, like, to do lookups in tables that are very large compared to the shard size,
Yeah.
You're going to need to do some cross shard calls.
Agreed. Okay.
For a read-only transaction.
Yeah.
And so, like, that's the case where you really want this optimistic execution.
Yeah, I just think that there's a trade-off, and the main thing is I don't want the trade-off to be the particular choice to be worse than the I don't want the solution to be worse than the problem. And the thing that I'm concerned about here is that the particular choice of solution for so I agree with you that speculative and optimistic computation makes a lot of sense. I tend to want to localize synchronization as much as possible.
I agree with you totally. I mean, but the idea is just like first we'll use global synchronization to manage shards, and then we'll shard the mechanism by which we're managing the shards, and make it more and more localized.
Okay. I mean, yeah. I mean, in principle, this makes sense, and I mean, I think we're going to probably have to revisit this a few times.
Yeah, probably.
And I think at the end of the day, it's kind of eventual consistency. The heart of eventual consistency is that you're constantly being optimistic.
That's right, yeah.
It's like the perpetual fool. So yeah, I hear you, and I do understand the desiderata that you're describing. It's also the DNS question. I think is a really interesting one as well, but I don't think we can go there today. So speaking of which, it's 8:15. I have a 9 o'clock that I have to prepare for. What do we want to? Well, I mean, I feel like we're starting to really make some progress. I'd love to do this a little bit more frequently than once a week. Also because like Aaron and I didn't get a chance. Aaron and I had some really interesting conversations yesterday about optimizing the IFS-based approach to convergence. And I would like to, maybe Aaron, would you be up for finding another time this week to go down that path?
Yeah, we had a Wednesday meeting a while back.
Yeah, you want to do Wednesday again? Okay, cool. All right, I'm totally down with that. Also, if anyone, I'm updating the document that I posted into the research group, which is kind of a progress update. If anyone else feels like they want to add, progress updates to that, feel free. I'm basically just describing it from the point of view of, the work that I've done with, on the ETH Dev grant. So comments are most welcome. I still haven't finished writing up the results section, but it's certainly changed since Saturday. So if anyone wants to give some eyeballs to that, I've already sent Wendell a link to the draft, so he can see that it's it's the state of the draft, and hopefully I'll have it done, I don't know, by the end of this week. But yeah, I would appreciate it if anyone wants to take a look at that.
Yeah, definitely.
Cool. Any other comments or burning stuff before we sign off?
I'm just excited to reverse some transactions.
You got some checkered past that you want to undo? Okay.
No, I just want to go so fast that I just make tons of mistakes.
and the corrections can never catch up with you guys.
No, we're just gonna synchronize somehow.
Okay. All right, guys. It's another excellent meeting. I'm looking forward to talking again on Monday, and then Aaron, you and I can talk on Wednesday. Is that right?
Yeah, that's great.
Awesome. Thanks.
Cheers.
Ciao.
Thanks, guys.
See you guys.
All right.
See you.